Hey guys, this is a video to help prepare you for the lab that we're doing today. It is called Can You Build a Stronger Electromagnet? And this lab is actually two labs in one. So we're going to do one lab all together, and then you're going to divide and conquer and investigate a different IV and DV. So the background, basically you're building an electromagnet, and then you're going to change the number of wire winds around the core to determine if the number of wraps affects the strength. But you're like, seriously, what's an electromagnet? Hold up. Here it is. In real life, this is where you might have seen electromagnets before. Think of Toy Story 3. I don't want to think about it too much because that part did make me cry. So at the very end, they were in that junkyard, and there was this magnet that picked up all the metal pieces. The magnet was powered by electricity, hence electro, which does mean electricity. And then you got magnet, which means magnet. Pretty simple. So in the junkyard, this magnet is used to separate the metal, which then can go and be melted down and recycled from the rest of the trash, which then could be burned and incinerated. So it's on this big crane doohickey thingy, and that magnet then separates the metal from the trash. Well, we are not going to build a crane doohickey thingy, but we're going to build a smaller electromagnet out of nails and wire. So you're going to take a nail, and it's a steel nail, just got it from Lowe's, and you're going to wrap wire around there. Notice how the nail looks very nice. The wire is wrapped very nice and neatly. This will help the nail become a magnet. So we will ask you to wipe the wire around perfectly nice and straight and not overlapping, not just because we're picky people. We are picky people, but that way also the magnet works, because look what happens. Since the nail is iron or steel, I think the ones at Lowe's I got were steel, which steel has iron in it. The little domains in the nail then become all aligned. So all the domains inside that metal nail go in the same direction. We can call it one direction if you like. And since all the domains are going in one direction, it becomes a magnet. And it will start picking up the pieces of metal, like a paperclip. You disconnect it from the battery, no more magnet. This paperclip will then fall down, off it goes. So that's what electromagnet is. When it's plugged into the battery, the electricity goes through all these wires that are wrapped around here, and as the electricity goes through, it influences the atoms inside the nail, and then the atoms go in one direction, and the nail becomes a magnet. It's pretty awesome. Okay, so for our investigation, we are going to determine what is the effect of number of wraps on the strength of electromagnet. So on your little half blue sheet, I want you to fill in the rest of your problem statement. I think I wrote half of it on there, and you just got to finish the other half. So you're going to write in the strength of the electromagnet. So basically, I'll get one started here while you're writing it. Basically, you're going to take your nail, and you're going to wrap the wire around there. Again, being very, very careful that the wire is going in the same direction. You can't crisscross it, or the domains will get crisscrossed, and it's no longer a magnet. And then we're going to wrap it different amount of times. So for our IV, remember IV stands for independent variable, or for a trick, it's what I, as a scientist, as an I, it's a very bad letter, what I vary. And the word vary means change. So I, as the scientist for this experiment, is changing the number of wraps. So that's what you need to write. This means number of wraps. So before that was a hashtag, that sign was called a pound sign. It means number. So number of wraps. And we're going to wrap it first 10 times. And then we're going to do 20 wraps. And then we're going to do 30 wraps. And then we're going to do 40 wraps. This here, the number 10, is your control. Usually our control is 0. But look what happens. If I have 0 wraps around my nail, this is so magical. 0 wraps means I have a nail. It's no longer electromagnet, so I have to wrap it sometimes. like a few times. So 10 is going to be our minimum, and then that's going to be our baseline to judge the rest. So we need to wrap it 10 times just to see what happens when 10 wraps are there. And then we're going to compare the 20, 30, 40 with this 10. So that will be our control. Again, a control means the baseline, the lowest number possible. Then the DV, the data we're collecting, we're going to be seeing the strength of it. So the strength of the EM. EM stands for electromagnet. Feel free to use that abbreviation this whole experiment. So strength of the EM. That's what we're going to determine. We're going to see how strong this puppy actually is after we wrap it 10, 20, 30, 40 times. We need to start thinking about things we need to keep the same. So I want you to pause the video and brainstorm a couple ideas of the conditions you want to keep the same throughout this experiment. Keep in mind, we're using wire, batteries, a nail, and staples. Staples are going to be what we pick up. Okay, welcome back. I hope you have a good list. Okay, so here are some things I want to make sure you think about keeping the same. You want to keep like the size of the wire. Oops, I changed colors. You want to keep the size of the wire the same, and by size I mean thickness. Wire comes in different thickness, so when you go to the store you can buy different fatnesses of wire. This is 18 gauge, like the bullet gauge or the holes in your ear gauge. Those are called gauges because it talks about like the fatness of a circle. So we're all going to use the same exact wire for this experiment. We're also going to use the same length of the wire. It's 100 centimeters. Everybody's in the whole room is 100 centimeters. We're going to use the same size of nail. Have you ever went to the store and bought nails before? There are tons of nails that you can buy. I had a field day going there. So we're all going to use, it's about 10 centimeters, it's a little over, maybe 11 centimeter nail. We're going to keep it down to one battery. So the number of batteries is going to stay the same. For that purpose, the number of nails is going to stay the same. We're going to use one nail in the middle. You could have more. Also, the type of staples. Mr. Mills has this gigantic staple gun. We could use its staples. They're bigger. But we're just using normal standard staples as for our experiment. So those are 6 ideas. There's other ideas that you could write for your constant conditions, but you just can't write the word nails or wires or batteries. What about them are you keeping the same? And what condition do they need to be? Okay. Now that you kind of understand the experiment, I want you to make a hypothesis. So remember, Parkway is pretty picky. We have to have you say the words if and then. I already typed it for you, so you just got to fill in the blank. If the number of wire wraps increases, then the strength of the electromagnet will. What do you think? Do you think the electromagnet will get stronger if you have more wraps? Do you think it will get weaker? If you do, write decrease. Do you think the wraps don't matter? And if you think it's going to stay the same, write stay the same. So as you wrap the nail up more, and 40 wraps is quite a bit, then it's kind of hard to get 40 wraps on this. You get them hanging off the end there. So as you wrap it more, what's going to happen to the strength of the magnet? Think about those domains. What they're going to do as it has more electricity influencing those domains. Okay, so at this point, your lovely science lady is going to be passing out a data table. I'm going to show you what it looks like. Where's my cursor? Oh, there it is. Okay, so you're going to glue this into your notebook, and you're going to, I don't know why the word constants there, ignore that. You're going to do a couple trials. So your group's going to be in charge of one trial. The next group is going to be in charge of the next trial. Group 3 is going to be in charge of trial 3. Group 4 is going to be in charge of trial 4. Group 5 is in charge of trial 5. And group 6 is in charge of trial 6. So you really only have to do this experiment once. And your group is going to record their data on here. Okay? And then you'll just average all the groups at once. That way you don't have to do this several times. to save some time. Oh wait, oops, didn't know that did that. Here's some lab tips. I put the staples with some Edwards, and I put the staples in a Dixie cup. Wow. I want you to nicely take those staples out of the cup and make a pile of the staples on the table, and you want to like loosen them up. For some reason they get kind of tangled, but when you dip your nail in there, you want to make sure they're kind of like easier to grab. Okay, and then when you do this, you're going to want to dip the tip of the nail. So you see the tip of the nail right here, oops, attracting a paper clip. Oops, goodness gracious. So dip the tip, good grief, dip the tip of the nail into the pile. And you're going to want to dip it one time. If you were like dip, 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 you're going to have another variable. So dip it, then forget it. No double dipping. Finally, wrap nicely, not just because I'm a very picky person. So I want your wraps to look like this, not like this. See how they're overlapping? That nail will not be as effective as a nail where the wraps are not overlapping. So be a nice and neat person for this time so you can see a difference scientifically. Alright, finally, I'm going to have you set up your graph. Okay, so your graph, remember the rule? This is your axis, this is your y, can't draw straight, and this is your x. The D goes down the Y. See how the Y axis makes the D? So the dV goes down. So I already wrote for you strength of electromagnet. And we're measuring the strength today with number of staples. Remember earlier we measured the strength with paper clips? To this experiment we're using staples. So write strength of electromagnet in parentheses, write number of staples. The IV goes across. So the IV today is the number of wraps. And you will have like 10, 20, 30, 40 wraps. So if you want to write those already, you can. So 10, I'm skipping to 20, skip to 30, skip to 40. Notice how I skipped the same number all the way around. And look at this here. That is the letter or the number 0. 0 is the origin of the graph. So I put it at the very origin. And it's for the y-axis and for the x-axis. We've been having troubles writing 2 zeros on a graph, so you have to have only 1 0 with everything spaced out evenly. Graphing is extremely hard, and we're pretty picky people about our graphs. So take time, get your graph ready. You'll thank yourself later when you're up to graphing. And then at the very end of your experiment, after you collected your data, calculated the average, did your graph, you have one more piece to do. That would be your mighty conclusion. Your conclusion has the same 3 parts they've had all year long. The first thing you're going to do is make a claim that answers the problem. You need to include evidence, which means numbers from your experiment. So in ELA, your evidence looks like a quote from the text. You don't have a text here, but you have data, and that's great evidence, so use that. And then finally, you're going to state whether or not your hypothesis was supported. Keep an eye out for that word supported, because that means it means that your experiment went as you thought it would be, but it doesn't mean you're necessarily right, because your experiment could have been flawed. Finally, at the very end, you will have this lovely dovely lab quiz. And really, quiz is probably a bad word for it. It's a summative assessment. So this will count as a grade for for trimester 1, and it'll be one of the last grades that you will collect. So you're going to want to work really hard with this. This lab quiz will be the exact same as the other ones you've taken, so a smart child might prepare for it by looking at their previous lab quizzes that they've done this year. And it's going to be very similar questions, like what is your IV, DV, what are the constants, what was your control, and all that. So that is that. You will be handed a green set of procedures. I would recommend that you give one person in your group the job of reading those procedures, and that person needs to be pretty strict about it. Hey, we're doing step 1 run now, let's read it. And they actually read it out loud, and then the people do step 1, and then do step 2, then do step 3. Those procedures are written for a reason, and that's for you to read them. If you have any questions, please let me or Mrs. Edwards know, and we will gladly assist you. Later, skaters.